You'll be receiving an email with your instructions for the gift certificates for your lunches, as well as a quick survey, and of course the opportunity to reply back to us with any questions or comments from this presentation. So thank you all again for being here. Big thank you to you, Bryan, and the Micro Focus team for the content and for your knowledge that you're going to pass on to us, and the QAC team as well for coming together. For any of you who aren't familiar with Micro Focus, Micro Focus is one of the world's largest enterprise software providers. They help customers digitally transform their organizations and achieve growth, profitability, and customer satisfaction objectives, while also maintaining the ability to optimize their underlying business processes and overall business spend. They're at the heart of billions of transactions around the globe and serve a central role in thousands of business critical functions like testing, process automation, storage, infrastructure optimization, security, compliance, and more. Naturally, as QA consultants became a platinum partner to Micro Focus as we utilized their tools in a number of customer engagements to achieve success. QA Consultants has a 25-year history in the software testing and quality engineering arena. We deliver all of our projects from our head offices in Toronto. And up until recently, or I guess up until COVID-ly, all of those were delivered from our test factory. But now we're successfully delivering from our remote offices across the province. So we've divided our test practices across test automation, performance testing, our mobile center of excellence, and various other expertise, and as such have applied our tools and Micro Focus tools, pardon me, to achieve the success. So we'll be diving into a discussion today about those, and what I will do now, I'm going to pass off to our Director of Test Automation, Mr. Tony Giardini, for a quick review of one of those projects to help you understand how we've merged our two expertise together. Tony, over to you.
Okay, thanks, Charles. Hello, everyone. So as Charles mentioned, I'm Tony Giardini, Director of Technology and Test Automation Practice at QAC. And today, I'd like to take a few minutes to share with you all one of the QAC's success story by using Micro Focus UFT tool to automate the regression test for one of our biggest customers, which is Toronto Hydro. Okay? It's always nice, like, to share things that went well with us, with our professional colleagues, and somehow like contribute to their success in their test automation initiatives and projects. So that's why I'm here today. I really want to share some great capabilities that were a key factor for our success in Toronto Hydro test automation project. So firstly, let me speak a little bit about four main challenges that we faced in that project, and then like I will like share how like UFT were able to help and to support and address those challenges very easily. So the first challenge was regarding the time that the entire regression package would take to be executed. So in that particular Toronto Hydro project, the complexity of the tests were very, very high, not only because of the actions and validations that were required, but the end-to-end scenarios involved multiple applications with different platforms and technologies. And the actions performed in one applications triggered and affect other applications that had to be verified. So the time spent to deal with several applications and how many times, like how much time the execution like takes to switch from one application to another was really important to be considered by us. Then the second challenge that we needed to properly address was how we could build test scripts in an optimized way that we could minimize the need of changes in the future, right? Or even during the project, due to application changes, or how we could increase the reusability of them and avoid creating repeated test steps or even test cases, or how we could take advantage of building some data-driven tests or parameterized test cases. So we also face the challenge of dealing with the high interdependency of the test scripts that were needed to be developed, and how the real-time data generated during the execution had to be utilized in the subsequent steps of the same test case, or sometimes for different test cases. Then the third challenge that we had, and I think this is very common challenge for any of us, is how to properly deal with UI elements locators. How to efficiently identify them, organize them, and optimize them in a way we avoid breaking tests for any small changes in the application. And all of this you multiply by the number of different platforms that were required, so you can imagine the complexity. Furthermore, we had to deal with some complex UI objects, such as complex table or structures where some data had to be checked or saved to be used in a subsequent test case or test step. And finally, the fourth challenge in Toronto Hydro project was to deal with multiple environments in a single test. For instance, like having a specific application that runs only in Linux, and then that application triggers some data processing that needs to be validated in a UI, like a web application, and then something else to be processed in a Windows environment, and so on. So all this multiple environment was some challenge that we had. So I believe that many, if not all of you guys, have faced similar challenges, right? And had a hard time to address them properly, especially with the current test automation framework that we usually have in place in our organization. So let me quickly share some of the great results that we were able to get by using UFT in Toronto Hydro project. So the first was we were very impressed with how UFT was able to run complex test cases with multiple applications, with multiple platforms quickly. We were very worried about timing performance due to the opening or switching time in between different applications. But UFT was really good by doing that. The applications were opened and switched smoothly with no delays and with no execution issues, such as the time, the waiting time for that some applications take to be opened or maximized. We also realized how reliable it was. So no issues with the false positives or test case failure due to waiting time required for each application or platform. And similarly, inside the same applications, we didn't have any waiting time issues. The second great point to share was that some key UFT capabilities allowed us to make our tests optimized, generic, and reusable. So the way UFT user is organized allowed us to easily reuse test case or a set of test steps, and everything could be parameterized. For external data, we easily use the environment variables feature. And for persistent data situations, its data table methodology allowed us to simply store and reuse any data generated during the execution of the test in other test steps or test cases. Another thing was like dealing with the UI elements locators, which usually is something painful for the team and requires a lot of manual work to ensure like optimize like XPath or object locators are created. So that was a very easy and quick process with UFT. We had around 80% of all UI elements that we had to identify. Uh, and this considering all applications of different platforms, not only web, but like Windows or Linux applications. And we were able to use Uft capability to identify and record elements automatically. And the remaining 20% that required like a little bit of coding because we had like complex tables or data arranged in a tabular fashion or like similar like complex objects, but it was easy to be done by using the descriptive programming capability within the Uft tool. So our team could easily customize object locators or use some creativity to deal easier with complex objects. And then for multiple environments and platform, so Uft has some smart waiting time to handle applications like switching time or environments, or like easy way to customize them for a specific scenario that we had and we faced. So it was great to have such powerful test automation tool that could help us to address all those challenges easily and without the need of using external tools or building something from the scratch, right? And it would be really painful to build like from scratch, as you all might have experienced, right? That can support like so many diverse platforms, technologies, and could easily navigate across like different applications during the test execution. So that's my sharing. So UFT was really crucial for our success, especially the time that it took to the team to automate the regression package for Toronto Hydro project. So I stop here, and please feel free to contact me or any like Micro Focus team members for more details or how we all can take advantage of the UFT in your test automation projects. Okay, so Bryan, I turn over to you.
Awesome. Thank you, Tony. Thank you, Charlie, for the introduction. So welcome, everybody. My name is Bryan Cole. I am a practice manager at Micro Focus. So my job function is to make sure that all of the sales and pre-sales teams essentially know what they're doing and have access to the tools they need to do their job. That means I get to talk to the PM organization a lot. And today we are going to talk about a lot of the challenges that Tony and team at QA Consultants have faced over the years using tools like UFT based on how it works, object recognition, and all those different challenges that are going on. And these challenges are probably very familiar to a lot of you. And I should also point out, if you do have questions at any time, you're most welcome to come off mute and ask those questions. We do ask, there's a number of people on the line, just put yourself back on mute after you have your question. You can alternately use the chat feature inside of Microsoft Teams. I can see that. I will address those questions as they come up. Happy to make this much more interactive. So when we talk about the challenges that people face with automated testing, regression is great, but we're increasingly hearing about this paradigm of DevOps and shift left testing, and how do we get things included earlier in the life cycle? And the problem is that the pace of change is so fast that our tests just keep breaking. The developers love changing stuff. Log in? No. Log on is much more descriptive. And all of my object properties now break because it doesn't recognize explicitly a button called log in anymore. It's gone. This means that we can't get our tests built at the same pace that the development organizations are running, particularly if they're adopting things like agile delivery. This leads to a lack of test coverage, and that leads to a corresponding lack of quality. There's this idea that we want to get a lot of velocity, we want to fail quickly and identify that we failed and then put that back into the cycle. And sort of my stance here is failing quickly is terrible if we can be successful quickly. So how do we move towards that? And some of the limitations that we see around this is about that journey that all of us have been on as it relates to quality. When we started at manual testing before any automation tools existed, onto the lightweight and then more robust solutions, now we're at this point where we are getting to autonomous testing and machine learning and artificial intelligence. And this is what we're going to be talking about today, the fundamental restructuring of how UFT works, how it addresses all of the issues that the QA consultants team have figured out how to solve in that old style, and dramatically simplify the efforts that need to go on, and as a result, increase everybody's testing velocity and the ability to get those test assets built and the resiliency. There's a lot of things that we're going to be talking about as we go through this. So back in the day, we have all these different issues. Now we need to be able to work smarter. So when we do that, we need to start talking about what artificial intelligence is. And there are any number of different metrics that we can use. When we talk to business leaders, it's becoming increasingly a strategic priority. This is basically 5 out of 6 people saying this is critical to our business. IDC and other big firms are looking at this, saying this is going to be a substantial area of investment and use by nearly basically this year. And IT professionals are increasingly investing in their own skill sets and learning more about this. We're also seeing that businesses incorporating AI into processes, product services, and offerings is increasing today. This is the current numbers from last year, I believe. And that the cost pressures of implementing this and using AI to replace people so that we can free those human beings up to do things that AI is just incapable of. This could be basic call center support, other things along those lines, and that these are already enhancing productivity. These are already implementing a freedom to let us as people pursue much more creative and demanding technical efforts and free us from having to do the tedium and drudge work that is required to keep a lot of businesses running today. But what is it, right? It is essentially an area of computer science that emphasizes machine learning. This is one aspect of what artificial intelligence is. There's all these multiple layers. It is tied into the concepts around what data science leads to, with the complex dashboards and other reporting that you'll start seeing out of a lot of really intelligent tools and BI systems. But machine learning is a big subset of artificial intelligence. Fundamentally, it is a pattern recognition engine. The software is trained to do a task, and that task can be simple, it can be complicated. There's a lot of gradations in between. The pattern matching is the heart of it, however. And in this space, understanding what we're looking at is a key part of this. Give it an input, compare those to the expected results, and generate an output. Give me a report, tell me how things went. And we see this all over the place, whether that is AI systems that look at MRI scans and can now identify whether there are skin lesions or other things to interact with and understand better than some medical experts, whether that is understanding, is that a stop sign and should I stop? My autonomous car should be able to do that. We're going to see this explode in terms of self-driving cars in the coming decade, as well as customer support and chatbots. We're starting to see those in a lot of organizations, and they are increasingly able to handle that frontline support and address a customer need without people being necessarily aware that they're talking to or interacting with an artificial intelligence system. So why are we talking about this in the context of test automation? The problem here is that our assets change. The login button changes to the log on button, or to the sign on button, or we have these variances across multiple different platforms, and that change continues to accelerate as the development teams get better and better at delivering software in a faster, more agile way. And that takes a lot of effort. A huge amount of time and investment has to go into maintaining the multiple scripts that are often required to manage all of these discrete environments, and that leads to a high skill barrier. And certainly the QA consultants team has this skill set, and they're a vital part of this transition to this new future state, where they are going to become much more consultative about how to get good automation practices in place instead of coming in and having to actually drive the automation work itself, and become a much more strategic and valuable sort of interaction with a lot of our partner community on this front. The outcomes of these challenges, though, are you spend a lot of time doing maintenance and you get a relatively low amount of automation out of it. So we talked to a lot of customers. We have thousands and thousands of customers using UFT today. They all suffer from this problem. And we took a large step back to rethink this and say, okay, so what is the problem you're actually facing? Here is a sample use case. I have an application where I go and it's very e-commerce-y and I'm going to buy something. Well, to log in, I have on the Android app this type of a login button. On an iOS app, it looks like that, pretty similar. On a mobile web, it looks like this. And on a desktop web, it looks different yet again. These are problems for the object models, and they might look similar enough, but the underlying object hierarchy, and anybody who's used UFT would know this, is that the way an Android app might render those objects compared to an iOS app compared to a web browser are radically different from one another. And this leads to me needing to have 4 different test scripts. And that creates challenges with maintenance, that creates time to market issues. Let's take a look at what that looks like. So when we look at a specific example here, we'll play the little video. It's going to go through and say, okay, here is a standard UFT script that's going to go and drive against a mobile device at this point. And you can see we're interacting. This is a real device that's plugged into UFT. These are capabilities that were here. It's a Samsung G9, it looks like. And it's going to run the test, do its thing. Great, get my test results. Everybody has sort of seen this view of the world of how these types of tools work. So let's introduce a very small change to this. We're going to take the menu and swap its position with the shopping cart. We're not going to do anything else to the object properties. We're just altering the look and feel and the application functionality. If we were really doing this in developers, the object properties would kind of switch as well, and hopefully your script would still work, but this is illustrative of the example. So now when we look at this particular test and we run it, we're going to see that it's going to relaunch the application, and the shopping cart and the menu are going to switch positions. And there it clicks into the shopping cart, not the menu. And anybody who's used UFT has seen this dialogue before, probably many, many times. I've certainly seen it thousands of times in my career. And now we have to do a triage. And we're sitting here thinking, why can't it find the objects? We're on totally the wrong screen. We need to now go into the test flow and begin to look at what happened in the previous steps and try and figure out in triage. And this is all cycle time that our test automation engineers need to spend identifying what happened at this point. So what actually happened behind the scenes is that the object was based on that physical object properties, right? The button is called login. There is a profile menu. And when we switched these, the profile options could be not updated correctly. As we make these application changes, there are inconsistencies that get introduced that are irrelevant to the end use of the product. The shopping cart still worked as a shopping cart. The menu still worked as a menu, even though the object properties weren't, quote unquote, properly updated as the developers made those changes. It's only relevant to the QA automation effort. So because of that, we see a lot of fragility in our automation scripts. And that's where concepts like descriptive programming really come to the forefront. And that skill set that QA consultants has developed is so valuable and so useful in trying to address these types of problems. What if we could take a step back, though, and look at this like a human being? Because if any of us on the phone were asked, click on the menu and then click the profile button to log in, we would all be fine if those buttons had switched positions. That wouldn't pose a challenge to us as human beings, right? This is the goal, and then we have some follow-on, click 17T in the search field, click the search button, click the card icon. What we've done at this point is we've implemented an AI engine inside of UFT1. So this is now the new name for Unified Functional Testing. The name changed back in December to UFT1 as part of a larger UFT family. We're going to look at the screen the same way a human does using computer vision. This is an aspect of how artificial intelligence works. Computer vision is a big part of this. You'll see this a lot in self-driving cars. And that brain then uses the eyes to look at the application, and what it sees is fed back through the brain to identify what it's looking at. We're then going to interact using that brain as a neural network to understand what we're actually seeing. We're going to properly classify the objects on the screen. So let's give you an example of what that looks like. So what we're seeing here is a UFT script, and now I've replaced a number of the commands in this particular script. So we're going to run across two different devices, Android and iOS. On the Android device, the images are still switched around. And you can see a lot of these weird commands like AI util hamburger menu. So a couple of different things where we set the device. You can see the menu is on the correct side of the screen here. We're going through the process. We're going to type in these different things. It looks like a normal script. It looks like UFT commands, but what's actually happening behind the scenes is the AI engine is examining the application like you or I would and processing it without requiring any object properties. There are no objects in the object repository other than a few at the very top for things like the device to set the context. And now when we switch over here, we're going back around. It's back in the original position, and it's still able to correctly identify the hamburger menu as it goes through this. So this represents a fundamental shift in how these types of applications work, how solutions like UFT actually function under the covers, what the engine is doing. And we are investing heavily in this. There's many more enhancements I'm going to talk about. When we look at the reporting on this, we can see that it has a clear, this is what I thought the search button was. And there's a scoring associated with this. So when we look at different items that are in here, we can see that it's going to give us a scoring or a ranking of how this is going on and being developed inside of the system. So let me just pause real quick right here. So you can see there's this one. We'll just skip forward ever so slightly here. It's not going to come back. The engine itself, and this is a good question that's been asked, is being trained via screenshot data that we've collected from our customer base. And I'll talk more about the AI program that you can become a partner with, but it's essentially, we offer a feedback tool for you to send screenshots to us that we can include in our training models. And we rebuild the AI model using incredibly powerful machines that are necessary to build a neural network, but just like the build process for software could be really complex. Once it's built, it's just an executable and it runs really, really fast. So this process is something we do internally in our R&D organization. We are also going to be exposing the ability for secured customers like the US federal government, the Canadian federal government, and others who are kind of a little wary of just downloading source code from other companies and just running it in their secured environments to be able to rebuild the neural networks on their own as well. But it is a full neural network. I'm not going to get into that process of how to create them because that's a 3-hour talk just all on its own at this point. So this is great. The next step then is, how do I put a translator mechanism in place to get us closer to using natural language? Because natural language is a much more intuitive interface than a script. That previous script example looked like a script. It felt like a script. There were a lot of .click commands. There were a syntax to it that was very script-like. Where we want to get to is much more natural language, and that will be things like this. So this is a standalone utility that we provide, and it's going to say, okay, how do I build a test script using natural language? So first I need to have a mobile device. So I'm going to connect into our UFT mobile platform and pick a mobile device that I want to use and the app that I want to use that against, and that's part of that platform. I'm happy to talk about that, but that's really not the focus here. So now I've got access to the device, I can launch it. And there I'm now interacting with the real device. I want to identify what's on the screen. Go inspect that application and see what you can see. And here it's looking at visual elements, and I can see, okay, there's the shopping cart with a score associated with it. I'm this confident that that's what this thing is. And when I click on that object, it's going to generate a command that says, click the hamburger menu. And the hamburger menu is the specific little 3-bar thing. So now I want to add another step. I can just type these in if I know what those are. And it will understand profile as a specific thing. And I click the next step and refresh my view. Oh, there's username. What value do I need for this? Because it's a data entry field. So I'm going to type that AI demo into the username field and type AI demo 1 into the password field. And then I want to go in here and say, I need to add a new button to this. And I'm going to click on it. And what's that button going to be called? Login. Great. I can type all this stuff out using a variety of different mechanisms, depending on the type of class that I want. And if I need index, or if there's multiple buttons on the screen, those positional elements of, what if there are 6 login buttons? How do I find the right one? Well, I can use that relative object properties, the first one on screen, variety of different mechanisms to make this easy. And then in the search button, we understand search has a context as well. So we're applying a search into this, and we're generating a test script at this point, right? And I type in these values, hit the search button, there's my results. And now I'm going to look at text properties instead of visual data elements. Now I want to click on the text that says the HP NV17T touch laptop. And I can switch back to visual elements at this point and refresh the screen once again and click the big add to cart button at this point. So I can go back and forth through different mechanisms, different profiles, but now I'm saying, okay, now I want to identify this details button over here. It doesn't know what this is. This is a new type of object that we don't instantly recognize as something that our AI model is aware of. So how do we deal with this? So what we're doing now is we're saying, okay, we want to add in this new object using the feedback tool, and we want to tell us, okay, where is it? Here it is on the screen. This is the particular thing that we couldn't identify. This is a details icon at this point. Some additional comments in here. We need AI support for this icon, and I'm sending this feedback to Micro Focus. Now, there's a couple of things that we've done at this point over here before I get going. We have added a masking or obfuscation feature to this. You are sending just a screenshot of the application, but what if there are things like account numbers or usernames or other potentially personally identifiable information on that? We're going to give you the option to gray out or pixelate that data before you send the screenshot. This gives you the ability to put that screenshot into our AI learning data set. It's included automatically. It would be in the next nightly build that we go through to rebuild the AI engine. And we use it in one of two ways. We either take that in and classify it and say, this is a details button, it's a type button, this AI engine is exactly how that works, or we throw it in as sample sets now that the engine has had its training and it's going to get exposed to a bunch of different things that it needs to identify, and then offer corrections depending on how accurately it identifies it. So it's either part of the learning data or the testing data, and it gets used in a variety of different ways. And we constantly redo and reset a lot of this data as we rebuild these AI engines. The nice thing is anything that's submitted, when we rebuild it from scratch every day. So the model, what we've found, is never worse by adding more information. It's always continuously improving and getting better. And the more screenshot data we have, the better off things become at this point. So I'll just carry on with the video. So now we're just going to open up a more configured example that's got some extra mobile devices in here. It's the same script for the most part, but we've added in multiple different devices across iPhones and Android devices. We can see all this going over here, and it's going to kick off this test and run this exact same test across these multiple different platforms. What we're going to find here is that we're going to see different UI design patterns for different versions of the application, and the script itself won't care because we've understood things like the context of what a login screen looks like. It's not a mystery to us that a username field, a password field, and then a big button called login or sign on or something else is a process that is well understood that we should follow. So it's going through, it's going to zip through this over here, and now it's going to go down and do the mobile web. When it clicks on the sign on over here, it actually says sign in, not login. And yet the script is able to process this command without any issues at this point. And this is the core thing that we've started to implement, is this understanding that different words can have meaning in the same context. Whether it says sign in, sign on, log in, log on, those are all the same thing in the context of signing into an application. And what it actually says on the screen, or whether the developer makes a change, there's no impact at all on this. There have been a couple of questions that have come in. So the AI engine, can it self-learn? Kind of. We are giving you the ability to extend and enhance the AI engine independently of UFT itself. So one of the future directions we're going to do is the AI engine can be updated without having to reinstall a new version of UFT. But you won't be able to self-update on your own unless you want to deploy the full neural network engine to rebuild it from scratch. It's not going to self-learn as it executes. You need to recompile, essentially, the neural network. The images that are being shared for the AI training are never shared with anybody. So if you submit them to Micro Focus, we get to see them, but we never share those with any customers. And the carrot here is that, yes, you are absolutely helping make that AI engine better generally for everybody, but you are making it explicitly better for your particular application. The analogy here is I can look at various human beings and say, those are children, but if you show me my daughter, I'm going to be able to explicitly identify her very reliably as compared to just other children. This is the mechanism of it understands as part of the training data. It says, I've seen something like this before versus I've seen this precise thing before and I know exactly what to do with 100% certainty versus I'm 98% certain that I did the right thing. Another great question was, can I mix descriptive programming with the AI engine? Absolutely, yes. We have thousands of customers who between them probably have literally millions of test scripts inside of UFT on that object recognition model today. And to say in any way, shape, or form, throw all those away and redo it from scratch is a non-starter. You may absolutely continue to use those scripts. As those scripts require maintenance, you can maintain them using the traditional object repository and the traditional object recognition that you know and are able to use. You may begin blending in AI objects into those and insert one little bit that needs to be maintained using the AI engine. You may simply say, at this point, I wish to create a new script that is completely converted to AI. We're going to touch on that last point in just a minute as well, about some of the utilities that we've created to help you on that journey. So that's all mobile devices that I've been talking about. Let's talk about web. And this is all part of UFT 15.01, which was released 2 months ago, I want to say 2.5 months ago at this point. So we're going to run across Chrome, Firefox, and then a mobile device at this point. So I'll just start this a little bit here. And first we need to create our script. So I need to check to see if the hamburger menu is there because it's not present on a mobile device or on a browser, but it is on a mobile device. So the first time I'm going to do this, I'm just going to type in the command. I know what a hamburger menu is. I've seen this command before. I'm going to do .exist, same kind of object properties. If it exists, then I want to click on the hamburger menu to open it up so that I can see the profile. Well, let's talk about the object spy. The object spy is probably familiar. There's the profile option here inside of the web application. And now at the bottom, it can see here is how the AI engine recognizes this. And I can drag and drop that into my script and get an AI profile click at this point. And now I want to say, okay, clicking on the profile, here is these screens. Let me open up the AI engine and let it look at this website and I figure out what it can see. And here's all the things that it can see on the screen. I'm going to drag and drop the username, the password, and then the login button onto the screen itself. Even though it says sign in at this point and says login in the mobile device, we're still going to be fine. And I can see there's other buttons like search and there's the profile button and shopping cart. If I need text, I can simply say switch from visual elements to text elements. And now here's all the text I can see on the screen. So if I wanted to click the forgot your password link, there's a link for that as well. So great, I've got this here, but of course, these inputs for username and password require text properties. I have to pass it a value at this point. And now my test is done. And I'm going to run it across 2 different browsers and a mobile device without needing to do anything else. There's some context setting stuff at the front up there as well, just to make sure that it understands how to access the mobile device. So here it's going in, typing in the username password. That's great. Here it is loading it up on a mobile device. And it's going to go through, check and see if the hamburger menu is there. If it is, it's going to then go in, type the AI demo, the password, and click the sign in button. And the fact that it was able to do this without requiring any rescripting across those different environments, it understood here's the username that I typed into the web browser. Here is the username that I typed into the mobile device. It sees and understands this context in the same way. If I look at other examples of objects that are on the field, the sign in button, for example, on the web page, it says sign in, but on the mobile device, it actually says login, and the script was still fine. This is the type of context that we put into how we understand what these objects are and what we're doing at any given particular moment in time. The cloud-based, so the question was, is there a non-cloud-based solution, or does the AI engine work only by submitting screenshots? We are going to offer the on-premises version for you to do it yourself, but generally speaking, yes, you would be submitting them to essentially a web service that we gave a little UI on inside of UFT, and you can send the screenshots to us to now include in future revisions of the AI engine that you can get from us as well. And like I said, there are many customers who are going to say, we're not going to do that, but we still want to use this engine. To them, we say, okay, great. Here are the mechanisms by which you can do this yourself without ever involving us, and give you that capability to do it on your own. Essentially, how neural networks work, ours has, last time I checked, 148 layers of compute that goes through it. We essentially strip off the last one and give that to you, and then your training set then recreates that last 148th layer and generates a model that you can then use as an output. So there's a lot that goes into that, but I'm not going to go into that. Another example over here, going through multiple different browsers and versions, but now with the UFT in dark mode, which is vastly better if you are like me, you definitely prefer dark mode for everything. The object repository is empty. There's nothing in this object repository. There's no trickery here. There's no random parameters. There's no complexity being passed into this. It is as straightforward as we can make it to illustrate that there's no object maintenance that needs to take place as we go through this. And it's going to run through a bunch of different devices on different platforms. And we kick off this particular test and off it goes. So it starts off, it's going to launch my environments, run through the device context setting code, and we are happy to share the code examples and copies of this presentation if you want to see it. This is Advantage Online Shopping. This is our online demo site that we use here at Micro Focus. And you can see it's going in and it's going to start looking at the screen, identifying the object properties, and going through and identifying the different fields and typing in values, interacting with the application. It is no object recognition. So this works regardless of whether I'm in Chrome or Firefox, whether I am interacting with a Safari browser, whether I'm interacting with IE, even if you're still using that, or the new Edge browser. These are all different supported environments now. Any mobile devices are included as well. What we are working towards is true Windows desktop recognition for all of the non-web, non-mobile devices. We figured out how to limit the scope of execution. When we initially released this, we released it just for mobile devices about a year ago, a little more than a year ago now. And we've recently added web because we finally cracked how to limit the scope of this, because we want to make sure that it works properly. We don't want to put out a solution that leads to things like false positives. You know, Tony talked about that. That's a bad thing. We don't want that, and we don't want false negatives either. There's nothing wrong. You should deploy this. Making sure that it's resilient and fully functional is great. We've also found, however, that using things like different VNC sessions that are browser-based like Guacamole does lead to a huge amount of object recognition on traditional Windows-based applications. So there's certainly a lot that we can do with this, because a button is just a button, whether it's an SAP button, whether it's a web button, whether it's a Power Builder button. That's the future that we're heading towards, where that giant checklist of UFT options that you need to select from for different object property sets that you want to load goes away. You won't need that, because we're just going to look at the screen like a human being does, leveraging this AI engine. So you can see it's going through this. There's typically a question around the performance that comes up from this. So certainly doing a mobile device, there's a little bit of latency and performance added to that. The mobile devices tend not to be as robust a machine as a desktop computer. But the AI engine itself is, in fact, a little bit slower. It has to visually process what it's looking at on the screen in order to correctly identify the objects and parse out what it's looking at. That delay was actually the biggest delay in us releasing the functionality at all. We had to get it down to taking as long as about an eye blink. So generally about a tenth of a second or so for it to look at the screen and properly triage and identify what it's seeing on the screen was the benchmark that we were interested in getting to. And that's what we accomplished about a year ago. So you might see a very small increase in the execution time of your scripts, but it should be pretty small. There shouldn't be a lot going on inside of that. Specific to these devices, we're leveraging either Uft Mobile or the Uft One device manager. So current versions of Unified Functional Testing give you the option to plug a device in just using the USB cable to the machine, or our own software solution for hosting mobile devices to build your own lab. But we can integrate with cloud and third-party device providers as well. And a number of our partners offer this as a service, and as well as larger enterprises like AWS has their device farm, for example. We can integrate with that and consume devices from that. So there's a lot of different things that we can talk about on this one. I'm going to move quickly through these last couple of examples here. So this is a traditional script written against a Fiori application. Traditional object recognition, different categories that it's going to go through. I'm not really going to play this video. I'm just going to skip to the next one because this is traditional, where we say, okay, that's great. How do I convert this to an AI script? What do I do at this point? So the first thing you do is you go to our marketplace and download a little function library that we've provided, and then you add it here into your Uft execution. You add that AI awareness function library. Now that it's added in here, you play your script, and that's all we're gonna do. No changes. We have a fully functional traditional object recognition script. We've added that function library. So now I go through and play this, and I'm just skipping past the actual execution part. If you haven't seen an SAP Fiori application, this is the publicly hosted SAP HANA Fiori app that you can go and poke a stick at as well. Just going to skip past all of this till we get to the Uft part at the end. There we go. Okay, so now we look at our results. And what we see in here is you could take this object and replace it with this AI util command that's in here. And we're doing this for multiples. Here in the traditional object recognition script, it says browser, shopping cart, .page, shopping cart, .web element, first available product, .click. You can actually change that to AI util, find text blocks available from the top, the first one, and hit the click button on that. And we'll find the first instance of the word available from the top of the screen and click on it, and without any object properties or anything along these lines. So as we talk about this migration from traditional object recognition scripts to AI-driven scripts, we're providing utilities to try and make that transition as easy as possible for you so that you can really transition everything over. Uft itself does support Oracle Forms automation today. Whether the Uft AI engine supports it, because there's some parts of it that are web-based and some parts that are Java-based, I'm a little unsure. That's a good question. I could follow up on that. I don't want to do a blanket yes. I feel like the answer is yes, but I've learned not to trust my feelings. I've learned to trust data a lot more than that. And then after we've gone through this exercise of converting it, we can say all of these objects can now be removed from the process. And we can say, get rid of all of that. Here's a screenshot that we've taken. Now we're going to go through and reload a different version of this application post AI. And the reason we took that screenshot here in the video is there is our script. At this point, we can play it. It will work exactly the same way. There's nothing fancy or different about this as it goes through the exact same process and executes exactly the same actions, which again, I'm happy to share afterwards. But now when we look at things like our results, we see that we're just clearing the cache and maximizing things like normal good automation practices. We can see what we're interacting with and the scoring that it's giving on what we think is the right thing to do at any given point in time. But the object properties are blank, and when there's just nothing in it. There's that one little shopping cart placeholder, and you compare to what we had before to what we have now. There's nothing to maintain in this, and this is the future state that we see and that we want to move everybody towards. Because when we look at this, we're seeing across our customers that are currently deploying this, the maintenance costs on their existing automation assets dropping precipitously. This 70%. And this is a huge transition in terms of how you're going to be able to start interacting with Uft more. A lot of our customer base doesn't fully optimize Uft. They are driving a lot of test automation. They're doing great things with it, but it's not running constantly as we start to see with customers investing in the AI because the reliability is going up so much. That automation coverage begins to skyrocket. If your engineers are freed up from having to maintain all of these test assets, they just continue to work. That means they have much more time to do more. And this is something called the efficiency paradox. We hear this from a lot of customers, and I'm sure QA consultants has heard it a number of times. If we implement test automation, does that mean we won't need as many testers? And nothing has been further from the truth across every organization I've ever talked to. The QA teams tend to expand and grow in size because the value of the quality ramps up, and there's a business recognition that that's actually worth paying for. We should do more of that. Yes, we can actually do some work around Appium and Selenium. You're going to have to wait till November to get a more comprehensive answer to that. The question just came in. We're seeing test development time drop as well. Tests tend to be created about 3 times faster because a lot of the nuance of how to manipulate objects and get things to recognize properly falls away. So you're much freer to focus on the business process itself. And we're starting to really try and eliminate that skill barrier so that a lot more people can participate in this testing process, especially business domain experts who have a lot of knowledge about how the application works and how they can drive a transaction and an understanding whether the application is truly working for very complex tasks. That's all required still. The skill about how to partition and what to automate and how to go about a lot of best practices, there's certainly nuance that's still left in here. That's where organizations like QA consultants are going to be required. But boy, are we trying to make this easier, and it's having a dramatic impact across our customer base. I also mentioned something that we call the AI Customer Club program. So we are more than happy to have you join the program. It gives you essentially an opportunity to interact with earlier versions of our AI engine prior to us making it generally available in a specific product release. It is run entirely remotely. We're going to think about on-site visits later because COVID ruins everything. And we want to basically walk you through the idea that we would have an intro session. We would look at how the AI engine looks at your applications today, the UFT codeless applications, get ongoing feedback from you, get screenshots and other rebuilds, put it into the models and generate models explicitly for you, where we test to make sure that that hasn't degraded anything else. We've never seen it. We still test for that. But also make sure that it is working explicitly better for you, and then start putting that into the productized versions of the AI engine that we're going out with. And this includes a lot of direct interlock with our R&D team. So if you are interested in that, please don't hesitate to reach out. The Uft Ai capabilities have been introduced starting as early as version 14.53. That was last year. 15.1, which we released in May of 2020, included support for web environments. And the web page is really where we see the vast majority of UFT testing taking place, where we want to make sure that you're aware this is something you can take advantage of today with the current version of our software. If anybody has any questions, I am happy to answer them now. You're welcome to come off mute or type them into the chat, as many people have been doing. My name is, of course, Bryan Cole. You can try a trial of UFT if you want to go and download it, just at microfocus.com/UFT. And of course, if you need to reach out to the QA consultants team, by all means, please feel free to reach out to them. Thank you, Tony and team, for setting this up. I am happy to field any questions that anybody has at this point. But otherwise, we're at the end of the content. Does anybody have anything they would like to ask?
Bryan, there are a few questions in the chat if you'd like to address them.
I don't think I missed any in here.
Okay.
Yes, Michael asked one about Appium and Selenium script. So the Appium and Selenium side of things is coming when we look at our Uft Developer toolset. We built the AI engine as a separated SDK explicitly so that we could then work on it and get it functional inside of UFT1, but then take that engine in its entirety and put it into other testing tools that we have in our portfolio. So the Uft Developer product, formerly known as LeanFT, which is very much like Selenium. It works for the developers in their IDE. That will inherit these Uft AI capabilities starting in the November timeframe, and that will include, just as I showed, a view of taking an existing object recognition-based script and converting it to an AI script. That will also include the same thing for Selenium and Appium scripts at that time. So you have to wait till November for that functionality, assuming, of course, they don't change the date on me, as they are wont to do from time to time. Actually, what we're seeing, so Ken asked a question here as well, is the direction for Micro Focus to move more into Uft and away from Silk Test? Yes and no. What we're seeing is actually a fairly ruthless cut and paste of our intellectual property and functionality across the two products. And we're starting to see capabilities that exist in Silk Test starting to show up in UFT1 and vice versa, as the products are eventually going to harmonize and merge together into a single unified platform. But we are continually supporting both code bases, and we're making sure that any customers that have made a technology investment are going to be able to continue to get value out of that technology investment. The last thing we want you to do is say, oh, Silk Test is dead. Well, I guess I should throw away all those investments that I have. Nothing could be further from the truth. We want you to keep getting value from that software investment.
Okay, Tony, this is Paddy here. So, see, we have a certain set of a standardized automation framework within our organization, and we don't want tools to work in silos. We want to integrate all the tools and make sure that everything forms a certain standard. So, how open is Uft for integrations with the existing automation frameworks?
Incredibly so. So many of our customers have written their own automation frameworks, and big ones like CIBC is an example. Others use things like business process testing that we provide, and have built more of a framework around that as a starting point. Yet others have built entire engines that generate descriptive programming commands on the fly and generate things that way. Many different avenues you can pursue. We have also significantly opened Uft into what a DevOps tool chain would look like. So that would include things like plugins for Jenkins and Bamboo and TeamCity and other platforms to allow you to invoke Uft testing directly from a CI execution, so that we can really begin to incorporate that as part of the overall delivery process as your tool chain starts to come together.
Okay, and how about this visual testing? Is there anything with the visual testing you have for you in Uft?
Are you talking about insight-based recording?
Yeah, I mean, just like Applitools does, right? I mean, we have this images and other things, like where we compare the images pixel-wise.
Yep. So we actually partner with Applitools. There is quite a lot that we can do by integrating in with them, but there's also a lot of that visual comparison capability that's built into the AI engine as well.
Okay. Okay.
Any other questions that anybody would like to ask?
I think quite a good information, Tony. Thank you.
Okay, I guess this has been this is the end of the session. So I just want to thank all the participants. Thank you, Bryan. Thank you, Tony. Thank you, Charlie. Thank you, everyone who has participated. So in exactly right now, your inboxes will be hit with an email that has a link to claim your gift certificate card. So please do fill that form out, as well as we have a survey link. So we'd like to see what your thoughts are and how we can improve our content. I also have been recording this session, so I will be sending out an email with the link as soon as the session has ended.
Wonderful.
Great. So thank you, everyone. Please feel free to reach out to QA consultants and see how we can help grow your business. Thanks for participating.